Now the topic before us is understanding bitwise operators in Python, types, meaning and examples. So first of all, what is bitwise operators? Bitwise operators are special operators in programming languages that work directly on individual bits of a number. It means that bitwise operators are those operators which work on the individual bits of binary numbers. We talk with one another in English language, Chinese or French, Hindi or any other language. But whether computers understand our language, whether we can communicate with computers in this language, no. The computers understand only binary language. What is the binary language? Binary language is the language of zeros and ones. That is 0 and 1. Computers understand only this language. Computers also store information in binary format using zeros and ones. When we are talking about bitwise operators do not operate on these values, on any value. They do not operate on these values. They operate on the individual bits of these numbers, individual bits or individual bits of binary numbers. So now the question arises, what are the binary numbers or how they can be created or how we can come to know of the binary number of a number. Now we understand, firstly we will understand how we can convert a binary into decimal or a decimal number into binary. Now first, to convert binary to decimal number. Decimal number is the number which we are normally using 46, 75, 86, 90,000, any other number, 900, any number. These are the decimal numbers which we are using in our daily life. Binary is the only those numbers which the computers understand. If we want to communicate with one another or we want to write in binary numbers in an easy way, it is not an easy way to write in binary numbers. It is for the computers, they easily understand binary numbers. Now suppose there is a binary number 110. This is the number which the computers can understand because they can understand only the language of 0 and 1s. Now how to convert this binary number into normal number or decimal number which we normally use? So here we will write from the right side, on the upper side of that binary number, starting from 1, and we will go on multiplying each number by 2. 1 multiplied by 2, 2, again multiplied by 2, 4. If there is any number after this one on the left hand side, we will go in increasing multiplying by 2. Here only 110 is the binary number given. So here we have started from the right hand side writing 1, then multiplying by 2, again multiplying by 2. Now we will add, this is the binary number 110 binary. This is the formula which we will be using to convert the binary number into decimal number or the normal number which we use in our daily life. So here, where we have mentioned 1, we will take into consideration only those numbers where we have 1 and we will go on adding from left to right. So here 1, here is 1, 4 plus 1, 4 plus 2. So this is the decimal number or the binary number has been converted into decimal. This is the 6. Now to convert, what is the method to convert decimal to binary. Suppose we have a number 45 with us and we have to convert it into binary number. What we will do? We will again write that formula which we have used 1, 2, 4, 8. Go on multiplying by 2 from right hand side. 1 multiplied by 2, 2 multiplied by 2, 4, 4 multiplied by 2, 8, 8 multiplied by 2, 16, 16 multiplied by 2, 32. We'll go on writing these numbers until we get a value which is equal to 45 or which is less than 45. We will go on writing these numbers until we get a value which is equal to or less than 45. If we multiply it again by 32 is multiplied by 2, we will get 64. But 64 is more than 45. We want a value which is either 45 or less than 45. Here 32 is sufficient because it is less than 45. So now we will write 1. We will start from right side. We will write 1 below 32. What is balance? If we deduct 45 from 32, what is balance? 32 plus 13. How we can get 13 from these numbers? These numbers. We can get these numbers 13 by from 8 by adding 8 plus 4 plus 1. So all the numbers which we will be taking into consideration will be mentioned below by mentioning 1 below that number. Other numbers are to be mentioned 0. I again explain. We have 45 number before us which we want to convert into binary. We have written this formula 1, 2. Each time we have started from right hand side, written 1, multiplied each time by 2, and we are to write that value up to a position up to that point where we reach a value which is either equal to or less than that value. And then on the left hand side, which is the highest value, 32, we will write 1. And now we are to use our mathematical formula, addition. We will go on adding in 32 that numbers which will ultimately lead us to the actual number which has been given to us. Here the number has been given to us 45. We will go on adding with 32 those numbers which can help us in achieving the value of 45. Here below each number we will add 1. Here we have added below 32 1, below 8 1, below 4 1, and below. Here you will find that this is the binary number 45 is equal to 101101. This is the binary number of 45. So there is another traditional method. We will also learn, however, that form is somewhat difficult. What is that format? Suppose we want to convert 45 into binary. We will go on dividing 45. 2 divided by 2, 45 is divided by 2 and remainder is 1. 2 is 22 is divided by 2, remainder is 0. Now 11 is divided by 2, remainder is 1. 5 is divided by 2, remainder is 1. 2, remainder is 0. Here, each time the value is whatever we get is being divided by 2. 45 has been divided by 2. 2 multiplied by 22, remainder is here. 2 multiplied by 11, remainder 0. 2 multiplied by 5, 10, remainder here. 2, 2, 4 plus 1. 2, 1, 2, remainder 0. So we will go on this doing this exercise until we get 0 or 1 at the last. Here we have got 1 at the last. Now we will start from this point. 1, this 0, 1, 1, 0, 1. So we have been able to have the binary number. This is somewhat a difficult format. The earlier format which we had discussed here earlier, it is the simple a formula. We can say it a simple formula so that we can convert decimal number into binary number. Now we will understand what are the different types of bitwise operators. So first is bitwise operator is bitwise AND. This is the symbol. Another is bitwise OR. Its symbol is this somewhat straight line which is given in the keyboard below backspace. Bitwise XOR. It is this symbol which is in the keyboard above 6 symbol. When we use the keyboard where 6 is there on the above side, this symbol is there. Next is bitwise NOT. This is this symbol which is here in the keyboard when we use the 1, 1, 2, 3, 4 where it is written before 1 on the left hand side, this symbol is there. Then bitwise left shift, and another is bitwise right shift. Now we will understand each of these operators one by one. Now we discuss the first bitwise operator. First is bitwise AND. This operator compares each bit of two integers and returns 0 and returns 1 only if both the bits in that position are 1, otherwise it returns 0. Now let us understand what it means. Suppose we have a variable a and its value is 10. We have another variable b and its value is 13. Now we use bitwise AND operator and let us see what is the output. Now firstly we will have, as already told, bitwise operators perform their operation only on the bits, only on the individual bits of a number or only on the individual bits of a binary number. So firstly we will have to convert these two values, that is 10 and 13, into binary numbers. Into binary numbers we will convert. So let us see what a now firstly we will convert 10 into binary number, then 13. So as already told, to convert a decimal number into binary numbers, we will use a formula like starting from right, writing 1, each multiplying by 2, each 1 multiplied by 2, 2, 2 multiplied by 2, 4, 4 multiplied by 2, 8. We will go on writing these numbers from right to left until we get a value which is equal to 10 or 13 or less than that. We need not to write more than that. So here we have been able, if we go on writing these numbers 8 into 2, 16. So 16 will be more than both these numbers. So we need not to go after that. So here 8 up to 8 it is sufficient. So firstly in case of 10 we will write 1 because 8 is below 10. So here we will first write here under 10 we will write 1 because the computer understand only the language of zeros and ones. So after that what is left, we will have to use some addition formula, that is sum. When we add two values we can 10 after adding 8 plus 2. So below that number which we will be now using to make addition we will write 1. Before below that we have used the 2, we have written below that 1. Against all other values we will write 0. In case of 13 we will write what is 8 plus 5 is 13. So 8 1. How we can get balance 5? 4 plus 1. On left, on the others we will write 0. So these are the binary numbers of 10. This is the binary number of 10. This is the binary number of 13. So now what is given? When we are using the bitwise AND operator, it returns 1 only if both the bits in that position. These are the bits in that position, both the bits. That is, this is the bit of A, this is the bit of B. Both the bits in that position. This is same position of A. This is the same bit position of B. So what will be the, it returns 1 only if both the bits in that position are 1. Both the bits are 1 here. Both the bits are 1. No. In other positions it is not so. So what is result? 1 0 0. Because in all other cases there are no other bits which have value of both 1. So here we have 1 on both sides only one time. We have written 1. This is the final binary number which we have achieved, calculated after performing the operation of bitwise AND operator. So this is the binary number. Now we will convert this binary number into decimal. So what is the decimal value? Here it is 8 because other are 0. It are not to be taken into consideration. All these are not to be taken into consideration. Only one is to be taken into consideration. One is related to this 8. So what is the final result? 8. Print A and B. Output is 8. When we will use Visual Studio Code, that is the code editor, and we will use this values A and B and print A and B, the ultimate result which the we will get will be 8. Now another bitwise OR operator. This is the sign. This operator compares each bit of the two integers and returns 1 if at least one or both the bits in that position are 0, otherwise it returns 0. We take the same values A, B, 13. Now we use print A bitwise OR. This is the somewhat straight line B. It is to be written in smaller case. Now what is the output? We have already calculated the values 1, 2, 4, 8. In case of 10, we have written 8 plus 2. these were the values 8 plus 2, 1 0 1 0. In case of 13, we had mentioned 8 4 0 1. These were the value binary numbers. These were the binary number of A. These were the binary numbers of 13. So what is the final outcome after using bitwise OR operator? It results 1 if at least one or both the bits in that position is 1. That is, either of the bits here and here, either has to be 1. So then the result is 1. Here both the bits are 1. 1. Here one of the bits is 1. Here 1. Final result is 1. Here both the bits are here one of the bits is 1. Here 1. Final outcome is 1. Here also one of the bits is 1. So this is the final outcome 1 1 1. So now we will have to convert these binary numbers into the value by using this 8 plus 4 plus 2 plus 1. 8 plus 4 plus 2 plus 1. So the output will be 15, which we will be getting. That is, the Python interpreter will interpret this as giving the output as 15. Now bitwise XOR. This operator compares each bit of two integers and returns 1 if the bits in that position are different. If both the bits are same, it will give 0. That is, same value 0, different values 1. We again take the same example, A10, B13. We will now be using bitwise OR operator, bitwise XOR. So now 8. What is 10? What? This is the value of a binary number of 10. Now we take this is the binary number of 13. So now what is the final outcome when we use the bitwise XOR operator? If both the bits are same, it will 0. Both the bits are same only in this position, 1 and 1. Now in case of other, the bits are different. Different values are there, 0 1 1 0 0 1. Then if the bits in that position are different, returns 1. So in here we will write 1. So what is binary number which we have get? 1 1 1. Now we will convert this binary number into decimal. So what is will be, we get 4 2 and 1. 4 2 1. So the answer is 7. So this is the output which we will be getting when we will use code editor, and the Python interpreter will interpret the output as 7 when we will use these values and print function and bitwise XOR operator. Now bitwise not operator. The bitwise not operator is represented by the tilde symbol. This tilde symbol is given in our keypad on the left hand side of the key 1. It inverts, that is, this bitwise not operator inverts each bit of the integer, turning ones into zeros and zeros into ones. What it means? Suppose the bit value of a number is, say, this. Now this bitwise not operator will invert each of these bits. 0 will become 1, 1 will become 0, 0 will become 1, 1 will become 0, 0 will become 1. So now what will be the net effect on the value on the decimal value, what will be the net effect of this bit-not-wise operator? Now we understand the same. Applying bitwise not operator to a positive number typically leads to a negative number. Here we take the example of A is 15. So applying not bitwise operator will result the number into, generally result into a negative number. That is, the result will become negative. The value will become negative. The resulting negative number is effectively minus a minus 1. That is, here the value of a is 15 minus 1, it becomes minus 16. So if there is decimal value in positive, it will become negative, and then also it will be increased by one value. 15 has become 16, negative has number has become, it has become negative value. When you apply bitwise not operator to a negative number, suppose a is in a negative, and we are now applying bitwise not operator, what will happen? This will be the formula: minus parenthesis value of a plus 1. Firstly, we will solve what is inside the parenthesis. It will become minus 14. Minus minus will become plus, and the answer will be 14. So when the value in decimal is negative, it will become positive, and it will also reduce by one value. Now bitwise left shift operator. This operator shifts the bits of the left operand to the left by the number of positions specified by the right operand. Zeros are filled in on the right side. What it means? It seems to be very technical what it means, but it is very simple. Suppose there is a number, a variable given a, and it has certain value, decimal value. Suppose its binary number is this. When we convert decimal into binary number, the value comes this. Suppose we have been given a bitwise left shift 2. It means that we are to left shift all these numbers by 2 points. And what will be two blanks left on the right hand side? Here, there we will add zeros. That is, here we have added two zeros on the right hand side because we are to shift to left by 2 points. So we will write all these numbers. 1 has been shifted here, 1 here, 0 has been here, 1 has been here. So this is the position which has been occupied by zeros. That is, on the right hand side we have filled the zeros by that number of zeros which are mentioned here. Suppose if it has been here a left shift 1, so what would have been the case? Then this would have been the case. Now we understand the same in detail with the help of an example. Suppose we have a is equal to 6. Now we have been given a left shift 2, and we use print function. What will be the output? So now we will first convert 6 into binary numbers. As already told, this will be the format. The numbers have to be represented in binary in 8 bits or 4 bits. Here 4 bits will be used because the number is small. This is small, so here it will be 1 1 0 0. So 4 plus 2 is 6. Before that we have added 0 to make it 4 bit. If the bits were more, we would have made it 8 bits. So now what we will do, we will shift all these by 2 points, 0, 1, 1, 0, 0, 0. This is the position which we have get after making a bitwise left shift 2. That is, we have shifted all these variables by 2 points on the left hand side, and the zeros have been filled on the right hand side. Now what is the value which we have get when we convert it into decimal? This is 16 plus 8. This is 16, this is 8. 16 plus 8, this is 24. So we are not to discard first 2 bits. These 2 bits are not to be discarded when we are shifting these bits. We are to keep them. However, if there have been zeros, if there are zeros first, we can discard them. Suppose if here A is 5 and A is to be left shift by 1. So what is the output which we will be getting? So first we will convert it into binary number. So it is 0, 1, 0, 1. So now we are to shift it by only 1. So it will become 0, 1, 0, 1, 0. So now what is the output which we will get? 8, 2. So what is the result? 10. So the output will be 10. There is a formula to calculate what will be the output. Suppose we want to know the final output, what the bitwise left shift operator will result into. There is a formula to calculate the same. What is the formula? Left shifting x by n bits is equal to x multiply 2 raised to power n. Suppose a is 6. So if we write a left shift 2, so what will be the final output? So it will be, what is the value of a? It is 6. So what left shift 2? It means that we are to write here 2 raised to power. Here n means this left shift by 2. So it will be 24. If we write, say, a is equal to 5, a left shift 3. So what will be the position? So what is the value of a? A is here 5. So here what is the formula? 2 raised to power n. What is n? N is 3. So what will be the final outcome? 5 into 8. It will be 40. Now bitwise right shift operator. This operator shifts the bits of the left operand to the right by the number of positions specified by the right operand. The vacated bits of the on the left side are filled with zeros. What it means? It seems to be very technical. It is not that difficult. What is given? It is right shift. It simply means that we are to shift the bits to the right hand side. How many times we have to shift? The number of bits which will be given there. Now we understand the same with the help of example. Suppose a is given as 7. So now we are to right shift a, but is given print a bitwise right shift 2. So first of all we will convert this 7 into binary number. So what will be the binary number? Binary number will be this. 0, 1, 1, 1, 4 plus 2 plus 1. The values which we have considered 4 plus 2 plus 1, this becomes 7. This is the binary number. So now what is given? Bitwise right shift 2. That is, we have to shift these values to the right by 2 points. That is, these two bits will have to go outside. If there have been given a bitwise right shift 3, then we would have shifted these three to outside. So now here in this question, only it is mentioned bitwise right shift 2. That is, right side two bits will have to be shifted outside. And what will be the gap left on the left hand side will be filled with zeros. So what will happen? These bits have been, two bits have been taken out, because the what is mentioned here, two bits outside. So these are the bits which have taken place. One has come here, 0 has come here. This is the final result which has come. This is the bits. So what is the value of 1? It is simply 1. So the output is 1. So now if it is given print a right shift 3, what will be the position? So in that case, this was the value. So what was to happen? We will have to shift these three, because here it is written 3. So we will have to shift these three to right side, to outside. So what will come? 0 will come here. So balance will be filled with zeros. So what is the net output? Net output will be 0. So now we will discuss, we have now so far discussed all the bitwise operators in detail. Now we will do practice of these bitwise operators on code editor, that is Visual Studio Code. Now we will do the practice of bitwise operators on Visual Studio Code. So we start. A is equal to 24, B is equal to 12. Now we use print function and write A bitwise and B. So now we use the run function. Here you can see the output, it is 8. Now we write A is equal to 12, B is equal to 18, and again now we use bitwise OR operator. Now we use again run, and here the output is 30. The computer system now automatically considers, that is the Python interpreter automatically does the internal working, how it converts a number into binary number, whether it has to convert 0 into 1 or 1 into 0, or it has to compare both the bits on of A and B, whether it is to be converted into 1 or into 0. It is all its internal working. We are not concerned with that. We have already learned how we can ourselves arrive at the output when we are using bitwise OR operator or XOR operator or left shift or bitwise right shift operator. That was only for our internal for our calculation purpose. Here the when we are using a code editor, it will not show its internal working, it will only show the output. So now if we write A is equal to 26, B is equal to 24, And now if we use print A XOR B, so the output is here 2. If we use A is equal to 6, now here we are using left shift function 2. So here the output will be 24. Now we are using A is equal to 5. Print A right shift 2. So now the output is 1. So these are only for your understanding that while we are giving command, you while writing on a paper, we may use P in lowercase or uppercase. But while we are giving the command, we are to write P in small case. If we use P in uppercase, there will be error in the output. So these are the some special points which we have to take into consideration. Bitwise operations can be complex to understand at first. It is helpful to practice with examples and visualize the binary representation of the numbers to see how the bits are manipulated. So now we will do practice questions. You can yourself solve it. We will also solve it so that you can compare it with your answers. So now what is given to us? X is equal to 10, Y is equal to 15. Print X bitwise and Y. So now first of all what we will be doing, we will be converting these values into binary numbers. So how we will get the value of 10 into binary? It is in this way. In case of 15, we will get 8, 4, 2, 1. As already told that when we are to convert a number into binary number, we use this type of formula that we start from right 1 multiply by 2 comes 2, again 2 multiply by 2, again multiply by 2. We go on multiplying by 2 until we get that value which is equal to the value which we are to convert, or which is the value which is less than that. So we are to arrive the value which is equal to 10 or less than 10. Here we have arrived at 10, 8 which is less than 10. If we multiply again 8 by 2, it becomes 16. So 16 is also more than 15. So we will restrict it up to 8. So this is the binary numbers which we have get, or the individual bits of decimal 15 are this. So here it is given print X bitwise and Y. So bitwise AND operator returns 1 only if both the bits in that position are 1. Both the position in that position are 1. Here it is 1, it is 1. So here it is 1, 0, 1, 0. Both the bits are 1. Both the bits are 1, otherwise 0. Both the bits are 1 here. So what is the outcome? Outcome is 8 plus 2. This is 10. So here the output is 10. Next is x15, y20. So we will start from here, a 1, 2, 4, 8, 16. We have written up to 16 because here the value of y is 20. We will write up to that which is less than 20 or which is equal to 20. So what is, how we will get 15 binary number? How we can convert 15 into binary number? 8 plus 4 plus 2 plus 1. 8 4, 2, 1. We will write 1 below that figure which we will be actually using. We will be adding that figures to arrive at 15. How we can get 20? 16 plus 4. In case of others, we will be writing zeros. Now bitwise OR operator returns 1 if at least one of the bits is 1. So here, what is the position? Here 1 is there in at least 1. Here it is also 1. Here both the bits are 1. Condition is if at least one bit is there, 1. So here 1. Here one of the bits is 1. Here one of the bits is 1. So here we have this binary number or individual bits. So now we will convert it into actual number by using this 28, 30 plus 1, 31. So this will be the output. Output will be 31. Next is A is equal to 16, B 15, print A bitwise XOR B. So now first we will convert 6 and 15 into individual bits. So 6 will be this, 15, 8, 4, 2, this. These are the individual bits of 6 and 15. So now what is before us? A bitwise XOR B. So it returns 1 if one of the bits returns 1 if the bits are different. If both the bits are same, it will give 0. Both the bits are same here, it are 0. If the bits in that position are different, where it is different? It is different here. In case of different, we are writing 1. In case of bits are same, we are writing 0. So what is the final result? 1, 0, 0, 1. We will convert it using this. So what is the output? 8 plus 1, 9. So here in fourth question, it is given A is equal to 9, B 7, print A bitwise left shift 3. So here value of B has been given only to confuse us. There is no need of this value because we are concerned only with A. We will convert 9 into individual bits. We will start writing from left to right. Now we have written from right side. So now 9, 8 plus 1. So this is the binary individual bits of A. So now what is given? A bitwise left shift 3. So it means that 3 points will become empty on right hand side because here 3 bits will be shifted to left hand side. So here we have added 3 zeros and now we will write 1 here, 0 here, this 0 here, and this 1 will become here. So this is the position 1 0 0 1 0 0 0. So now what is? So now we will have to increase these figures by 3. So this is the position. So now we will add these. What is given? A represent first one represents 64 and this one represent 8. 64 plus 8. It is 72. So the output will be 72. So now what is next? A is equal to 5, B is equal to 7, print bitwise right shift 2. So again the value of B is not required in this case, though it has been mentioned only to confuse us. Now we will convert 5 into binary numbers, that is individual bits, to 1, 2, 4, 8. How we will get 1, 4, 1, 0, 0, 1, 0, 1. So now what is given? Print A bitwise left shift 2. That is, we are right shift 2. Here we are to shift these 2 bits to outside. Now we will be shifting all these bits to the right side. It means ultimately these 2 bits will we have to taken out. So it will come here. It will come here. So 1, 0, 0, 1. This will be the final outcome. So what is the result? This one will represent this value and the output is 1. So now what is given to us? X is equal to 7, print bitwise note X. So what it will result into? So first of all, we will convert 7 into binary number 1, 2, 4, 8. 4, 2, 1, 0. So now what we will have to do? We will have to inverse it. It will become 1, 0, 0, 0. 0 will become 1, 1 will become 0. This will be the result. As already told that we will have to check what is here on the left hand side, which we have arrived at. On the left hand side it is 1, leftmost bit. If it is 1, it means that we have to make it negative. If it is 0, it is positive. It means it is negative. So here it becomes -8. Others are zeros in not to be taken into consideration. So it is -8. Thanks for watching. If you like our course, please spare some time to give a star rating to our course.